Here in this question, 4 statements are given and we have to identify which of them are true. Statement 1. Complement of a CFL need not be recursive. This is false. Why? Because complement of a CFL must be recursive. So we can say statement 1 is false. This is false. Statement 2. If L is recursive, then L plus is also recursive. If statement 2 is true, if L is a recursive, then L plus is also recursive. Statement 2 is true. Statement 3. If L is recursive and L2 is recursive enumerable, then L2 minus L1 need not be recursive enumerable. This is also false. Why? Because if L is recursive and L2 is recursive enumerable, then L2 minus L1 must be recursive enumerable. So this is false. Statement 4. Recursive sets are closed under complementation and substitution. Recursive sets are closed under complementation but not under substitution. Therefore, S4 is also false. The only true statement among the given 4 statements is statement S2. So here correct option is option D.
Context-free grammar to accept the following language is L is equal to 0 power P, 1 power Q, 2 power R, such that P is equal to 1 and Q is equal to R. That means 1 0 followed by Q number of ones and R number of twos. Ones and twos are same, 0 is only 1 0. Or P is equal to Q and R is equal to 1. R means actually it is a union. Union of two CFLs is CFL. So P is equal to Q. Here zeros and ones must be equal and 2 is only 1, 1, 2. Or Q is equal to 1. Now in the number of ones is 1 and zeros and twos are same. P is equal to R. So for this we need to find out a grammar. So the strings that means there are three languages here, L1 union, L2 union, L3. Where L1 is P is equal to 1, Q is equal to R. L2 is P is equal to Q and R is equal to 1. L3 is Q is equal to 1 and P is equal to R. So here if we take the minimum string in the first case in L1, we will get P is equal to 1, 0, 1, 2 we get, or we may get 0, P is equal to 2 for example, R also 2, 1, 1, 2, 2, something like this. So here number of zeros is only single 0. After that we don't get any 0 for the language L1. L2, in the case of L2, R value is 1, number of twos are ones. So for example, if you take this grammar, yes, option A grammar, so you may get S2 0A, again A2 1A2 like this, again A2 1 2, this you get, but for example you take other things, those also must be satisfied. Here R should be 1, so more than 2 twos are also possible here in the case of this. 2 twos should not be possible, so that's why, so option A is wrong. Now if you take this option B, here also more than 1 2 is coming for this, so this will be applied for all these combinations, P is equal to 1 and Q is equal to R, or P is equal to Q and R is equal to 1, or Q is equal to 1 and P is equal to R. Take option C, 0A, 0B2, C2, A2 1A2 1 2, B2 0 B2 1, and then C2 0 C1, and then 0 1. So these are the productions. So we should have 1 0 in one case, only 1 2 in other case, only 1 1 in other case. So in this case, if you take S2 0A, if you want to take this first combination, A can be followed by ones and twos are same. If you want the second combination, that is R value is 1, that is C2, before C this zeros and ones can come. So that is third combination is Q is equal to 1, that is the middle value is 1. For that we can take this B provides only 1 and zeros and twos will be similar. So C is the right option.
Question. An SGT is given and three statements regarding that SGT are given. We have to identify the statement which is true. If we see the SGT here, we can say that this SGT is converting binary number to decimal number. This is converting binary number to decimal number. But statement S1 is given as it converts decimal number to binary number. So we can eliminate statement S1. S2, it is an S attributed grammar. S attributed grammar is nothing but a grammar which consists of all the attributes as synthesized. All the attributes are synthesized. Then we can say that the grammar is S attributed grammar. Synthesized attribute means the value of the attribute is dependent upon the attribute values of its children. So here we can see that this is one. So here we can see that the value of parent, the value of attribute of the parent is dependent upon its children. So it is an S attributed. All the attributes are only synthesized attributes. In this, attributes are only synthesized attributes. So we can say it is. So we can say it is an S attributed grammar. And the statement S3 is it is an L attributed grammar. Every S attributed grammar is also an L attributed grammar. So we can say both S2 and S3 are true. So your correct option is option D. Which of the following statements is true? S1. SLR1 algorithm can be used to build tables for LR parser but not LR1 algorithm. Statement 2. Both LALR1 and LR1 algorithms can be used to build tables for an LR parser but not SLR1 algorithm. And statement 3 is given as all SLR1, LALR1 and LALR1, all SLR1, LR1 and LALR1 algorithms can be used to build tables for an LR parser. Here among the three given statements, only statement S3 is true. So your correct option is option C.